Welcome to the itdvds.com YouTube channel. This is just a sample of the training available at itdvds.com. If you would like to see complete training, please go to itdvds.com. Now let's begin the sample. IP networks use IP addresses to communicate over the network. So anytime we're talking from one computer to another computer over an IP network, it needs to know the IP address to communicate with that other computer. It doesn't actually use the name of the computer in order to communicate over the network. The name, if we're using a name, is actually resolved to an IP address, and that's called name resolution. For example, if I open up Explorer and I go to / dc02.itdvds.local /C$, it looks like I'm communicating with the name dc02.itdvds.local, but behind the scenes, this name is actually being resolved to an IP address, and that IP address is actually what's used to communicate over the network. So again, that's called name resolution. And there are three main ways Windows handles name resolution. The first is Domain Name System, or DNS, and this is by far the most important method for name resolution. The next method is Link Local Multicast Name Resolution, or LLMNR, and this is only used by Windows Vista, Windows 7, Windows Server 2008. If we go prior to that, like Windows XP or Windows 2000 or Windows Server 2003, they don't use Link Local Multicast Name Resolution. So this is somewhat new. And then finally, Netbios. So it's going to try DNS first. If it can't use DNS, then it's going to move down, try LLMNR or Netbios, depending on whether or not it's using IP version 6 or not. If our computer's using IP version 6, then it's going to try LLMNR. If it's only using IP version 4, then it's going to try Netbios. But if it's using IP version 4 and IP version 6, it's going to try LLMNR first, then it's going to try Netbios. But DNS always comes first. DNS is the best, it's the most efficient, and Active Directory absolutely depends on DNS. So when we have a name like DC02 or dc02.itdvds.local, we're going to try DNS first. And it's important to understand the order in which Windows works to resolving a name using any of these methods. So for DNS, it first looks in its DNS resolver cache, also called the DNS client cache. And we have something called a host file. And initially, anytime we save the host file or reboot our computer or restart the DNS client service, the host file is loaded into the DNS resolver cache. So when we go to resolve a name like DC02 or dc02.itdvds.local, it looks in the resolver cache first. If it can't find it in the resolver cache, then it's going to query its DNS servers. And we configure those DNS servers when we configure a network card or by DHCP. So let's go over to a computer real quick. I'm going to just open up a command prompt here. So first, when I went to try to resolve dc02.itdvds.local to an IP address, which happened behind the scenes, what it did is it looked in its resolver cache, and we can actually look in its resolver cache by using ipconfig /display DNS. And this shows us the resolver cache on this particular computer. We can see there are a lot of different names here it has in the cache. And there's dc02.itdvds.local. We can see the record type, time to live, data length section, a host record, which we're going to be talking about later on, record name, record type, time to live. So this is the IP version 4, and this is the IP version 6 address, if it has one. And it's all in the cache. So right now, if I pinged dc02.itdvds.local, it would be able to find it in its cache and resolve the name. It wouldn't have to go to a DNS server. But if that name was not in the cache, then it would have to go to a DNS server to try to resolve the name to an IP address. So let's talk about the host file real quick. The host file is important to know about, and it's actually a handy way we can use to test a lot of things as administrators. So I'm going to open up a new Explorer here. And our host file is in our C drive, Windows, System32, Drivers, etc. So this is where our host file is at. And let's just go ahead and open it up with Notepad and take a look at it. I'll just right click on and open. It doesn't have an extension. It does not have an extension, so it's not like hosts.txt or anything. It's just the word hosts. So we have to select a program this way in order to open it up. So here's our host file. And here's some example of a few names here. Localhost 127.0.0.1. What it is we have entries. Currently there are none, but we have entries in this particular host file where we're resolving a name to an IP address. And this pound sign is a comment. So anything after this pound sign means that it's not actually read by the DNS client service and not put into the DNS resolver cache. So it's just something called a comment. So let's add a line. But with Windows, permissions are such that we actually need to open Notepad as an administrator to modify this host file. So I'm going to right click on Notepad here and click on Run as Administrator. Let's go to File, Open. And now I'm just going to browse to our host file. And that's at Windows, System32, Drivers, Etsy. And we need to go to All Files. And there it is, host file. Click on Open. Let's expand it out so now we can actually modify it. If we tried to modify it without running Notepad as administrator, we'd actually get a access denied or something like that. So I'm going to type in, let's say 192.168.15.15, and then I'm going to hit Tab. You can use space also, the space bar. And then we're going to type in a name. It can be a single name, like let's say FS01, or it can be a fully qualified domain name, and we'll talk about what a fully qualified domain name is in a second, like fs01.itdvds.local. And if I wanted to add another entry, I could, like 192.168.15.15. And for this one, I'll just put FS01. And I'm going to go ahead and save this. And when I save this, it's going to be immediately put into the DNS resolver cache. So I'll save it. Let's go back here. Type in ipconfig /display DNS. And we'll just scroll up here. There's FS01. You can see 192.168.15.15. So that's what we added to our host file. And here's fs01.itdvds.local. So now if I ping FS01, it comes back with that IP address. Now FS01 doesn't actually exist, so it's actually timing out. But you can see it came back with that IP address. So again, if it doesn't find it in its resolver cache, then it's going to query a DNS server. And I can just do an ipconfig /all, and I can see my DNS servers that I have configured. So for this local area connection, my DNS servers are 192.168.6.199 and 127.0.0.1. So let's say it can't find fs01.itdvds.local in its resolver cache. It's going to ask this DNS server first. That's my primary. Actually, ::1 is the primary. Then it's going to ask 192.168.6.199. Then it's going to ask 127.0.0.1. And if it can't get an answer, like it can't resolve that name to an IP address via any of these DNS servers, then it's going to move into our link local multicast name resolution or Netbios to try to resolve that name. And finally, just as a side note, I want to mention the host file is an excellent way to test changes that you're going to make to DNS before you actually do it. Because when we make a change to this host file, it puts it in the resolver cache. It's going to override basically what's on a DNS server. So I may go to make a change to a host record in DNS, but before I do that, I just make the change in my host file on my local computer, and I can test it out before I actually change the record in DNS and affect everybody. Also, it's a good way for development folks that have to deal with IP addresses and dev servers a lot to be able to make that change on their local computer and have a specific domain name hit a different IP address than you have in DNS. So now let's say whatever name we're trying to resolve can't be resolved via DNS. So the name's not in its resolver cache, queried the DNS servers, they didn't have any records for it, so there's no name resolution yet. So Windows is going to try. link local multicast name resolution if we're using IP version 6. If we're using IP version 4, it's going to try Netbios. If we're using both, it's going to try LLMNR first and then Netbios. So with LLMNR, it also has its own cache. So if LLMNR was able to resolve that name earlier, it's going to look in its cache and be able to resolve that name again. If not, it's going to try Multicast. Multicast is basically multiple computers are listening on the same IP address, and that's how it's going to talk to multiple computers. And the multicast IP address for IP version 6 is FF02::1:3. So it is a special address, and multicasts have special IP ranges that they use. For IP version 4, it uses 224.0.0.252. So it's basically going to send out an LLMNR query to this multicast address, IP version 6 specifically. We'll talk about why it doesn't really use IP version 4 here in a second. But so IP version 6 sends out a query to this address. Hey, does anybody know how to resolve this name? Basically, do you have this name? And if you do, what's your IP address? If they do, they respond back with their IP address. And then the name is resolved. So let's talk a little bit more about link local multicast name resolution for a second. This was designed because Netbios, which is a really old protocol, only works on IP version 4. So with the coming of IP version 6, we kind of need a name resolution that doesn't require any configuration, is simple, and works with IP version 6. And LLMNR does that. IP version 6 only by default. In theory, it can work on IP version 4, but with Windows, it's really not designed to, and it doesn't work by default. So if we're using IP version 4, we would use Netbios. Now, the advantage of LLMNR is there's no configuration necessary. So basically, your computers, if they have network discovery enabled, they'll respond to LLMNR queries. So we don't have to set up like a DNS server or something like that in order for this to work. Now, a couple of disadvantages here is it doesn't work with Windows XP or Windows Server 2003. So we got to have Vista, Windows 7, Windows Server 2008, or Windows Server 2008 R2. And again, it will only resolve computer names to IP addresses that have network discovery enabled, because those are the ones that are going to be listening on that multicast IP address. Also, this only works within the local subnet. So if you've got multiple subnets, you're not going to be able to use LLMNR to resolve one computer that's in a different subnet from a computer that's in another subnet. So you can see that's why this isn't very scalable at all. It's just a very simple way of resolving names, and it's really the response to Netbios' inability to work with IP version 6. So next is Netbios, and this is a very old protocol that's been around for a long time, and it's been a bit tough to get rid of. By default, with newer Windows machines, you know, Windows Vista 7, XP, 2000, 2008, 2008 R2, basically anything before or after NT, Windows NT, we have a certain order in which Netbios tries to resolve names. First, it looks at the Win servers. Then it looks at something called the LM hosts file, and this is just like the host file with DNS. And then if it can't find it that way, it's going to actually use an IP version 4 broadcast in order to try to resolve the name. Now, the order in which it uses these particular methods depend on the Netbios node type. And we'll talk about that in a second. Let's just talk a little bit more about Netbios. Again, Netbios is IP version 4 only. There's no configuration necessary. But with Netbios, it's going to be single name resolution only. So this is actually one of the issues with Netbios. So there is no like dc02.itdvds.local. That's called a fully qualified domain name. There would just be like dc02. So there's no way to differentiate between two computers that might be named DC02 with Netbios. So that's kind of a problem. And it makes Netbios not very scalable. And again, that's why DNS is the much preferred method, and that's why we moved to DNS. Okay, now let's talk about those Netbios node types. These are important to know. Broadcast is called a B node. if your computer is configured as a B node, then Netbios is going to use broadcast only to try to find our names to IP addresses. And broadcasts are generally considered bad because they create a lot of traffic on the network and not very secure if we're broadcasting out all the information on the network. Meaning if we're trying to resolve a particular name to an IP address, we broadcast it out and everybody gets that broadcast. So that's generally considered not very secure. Point-to-point or P node, if a node is configured as a P node, it's going to use the WINS server only. And a WINS is just basically a simple catalog, and we're going to look at setting up a WINS server for Netbios names to IP addresses. Then there's a mixed or M node. This is going to use broadcast first and then WINS. So try broadcast, then if broadcast doesn't work, try WINS server. Then there's hybrid or H node. If a server is an H node or a computer is an H node, it's going to try a WINS server first. If it can't resolve the name via WINS server, then it's going to try a broadcast. And hybrid is actually the default. And we can actually tell what type of node we're configured as if we do an ipconfig /all and go up here, and we can see node type hybrid. So this lets us know our Netbios node type. And finally, let's just talk about DNS real quick. We're going to be spending the majority of our time talking about DNS, so I just want to go over a couple quick points. DNS, again, stands for Domain Name System, and this is a hierarchical system. So we don't use like a single name. We actually use dots to separate a hierarchical system. And we have something called a fully qualified domain name, which means it's the full name. Like itdvds.com is a fully qualified domain name. It's not just itdvds. Or technet.microsoft.com is a fully qualified domain name. And the com is something called a top-level domain. Now, what about DC01? So this is not a fully qualified domain name. But if we have something called DNS search suffixes configured on our computer, if we go to try to search for DC01, it will actually append a certain DNS suffix, like itdvds.local, to this name and try to use DNS that way to try to query a DNS server to resolve the name to an IP address. And we'll talk about that a little bit more in a second. And one final thing I want to talk about with DNS is technically there's actually a period or a dot at the end of a fully qualified domain name. So it looks something like this, actually, with a dot at the end. And that dot is actually the root. So when we try to resolve, let's say itdvds.com to a IP address, what it's going to do is it's going to query the root name servers first. And there's something called root hints that we'll talk about in a bit that lists those root name servers. So it queries that for the com name servers. Once we know the com name servers, we query it for the itdvds name servers. And then we reserve the name or resolve the name for itdvds.com. Well, when we open up something like Internet Explorer, we would just type in itdvds.com. Behind the scenes, the dot at the end is actually added. So finally, let's see each of these methods in action. So first, I'm going to ping DC02. Hit enter. So what happened here? Well, we know it used DNS because we've got a fully qualified domain name. It came back with dc02.itdvds.local, and it actually appended that DNS search suffix for us, the itdvds.local, and was able to use DNS. So anytime we come back with a fully qualified domain name, we know we're using DNS. And one thing I do want to notice it came back with the IP version 6 address. If we want to force IP version 4, we could do a -4 at the end of our ping or in between the name. And you can see it uses IP version 4, but it still comes back with a fully qualified domain name, so we know we're using DNS. Now what about if I ping something that's not in DNS? I'm going to ping HP laptop and hit enter. Notice it did not come back with a fully qualified domain name, and it came back with an IP version 6 address. Then we know it's using LLMNR to be able to resolve the name. Now what about if I just force IP version 4. It still did not come back with a fully qualified domain name, but it's using an IP version 4 address, so then we know it's using Netbios. So that's each one of the methods in action, and the bottom line is all we're trying to do is resolve a name to an IP address.